Alright, so we looked at two ways to work out percentage composition. We decided that the shorter way, that was just as reliable, was an easier way to do it. So we're going to try and remember how we did that. First thing that we need to do is to record our atomic masses for every atom in our compound that we're working with. And the reason for that is that we then need to find the molar mass, and then we can find our percentage. So what we've got here is the atomic mass of iron is equal to 55.85. The atomic mass of oxygen is equal to 16.0. Okay. Using those numbers, we can see there's 2 irons and 3 oxygens in there. So we go 2 times the first number, 3 times the other. We get the molar mass of iron 3 oxide, and we'll just do that quickly.
When you round iron to 3,
Yeah, we will at the end.
Okay,
So we'll save our rounding until the very end. So I've got 159.7. Is that the same as you guys? Okay, which again, at the very end would probably round off to 160. Okay, now to find my percentage iron, there's 2 ways to do it. I could go the atomic mass of iron over that and then multiply it by the number of ions that are in there. Or I could find, so like it's not really a molar mass, but the molar mass of the 2 ions together, and then divide it by the overall one. Either way, the working looks like this. 55.85 times 2 over 159.7. 2 because there's 2 in the formula. Okay? The 55.8 because that's its atomic mass, and the 159.7 because that's the molar mass of the whole compound. To make it a percentage, I then need to go times 100. Okay, that makes it a percent. And I think you're going to get 69.9% for that if you use the exact values. Alright. So, as I say, the reason for the times 2 is because you've got the 2 in the formula. The reason that we worked out the molar mass is that's our total score, as it were, that we're working out a percentage from. Now, another one that I threw that was a little bit trickier was asking you to find the percentage of water in something. And this is actually linking it to that previous concept we did of water of crystallization and gravimetric analysis. So you could find from gravimetric analysis, you might find the percentage of water in a crystal, not just its, not just the formula for the hydrated salt. So the second question, find the percentage of water, in hydrated copper sulfate. Now, for this, my suggestion to you is to think of water as one entity itself. So you're not adding up the fact, oh, there's 4 oxygens there, but it's 5 plus, there's 9 oxygens. Don't work your way through it like that. I asked you to try to remember that the molar mass of water is 18 because it's going to be very useful for you. So I'm asking you to remember that now. Okay, so that's where it's going to be useful. So again, we're going to do our list of things that we need to know. We need copper, which is about 63.5. That'll do for now. We've got sulfur, which we'll say is 32.06, but we'll use 32.1 just for speed to get through this. Oxygen, 16.0, and as I say, we're going to think of the water as one thing together. So, and what I'm going to do is I'm just going to jot down a couple of notes myself so I don't make mistakes here. There's one of those, there's 4 of those, and there's 5 of those. I'm jotting these notes down just so I don't make a silly mistake. Because there's so many things to add up, I can imagine making a silly mistake. So, my molar mass of the hydrated salt is going to be 1 times that, plus 1 times that, plus 4 times that, plus 5 times that, 249 point something. I'm going to need some help there, please. 249.6. Awesome. Okay. Then I look at the fact that I've got 5 waters, so I'm going to go 18.0 times 5, because there's 5 in the formula, over 249.6 times 100 to make it a percentage. And I'm going to need some help with that one because I haven't done this one yet.
36.1.
36.1%. Okay. So there we are. There's two slightly different ways to look at it. One is just looking at the percentage of a certain atom. It is actually probably the useful element in that if we're trying to extract it. And another one is finding the percentage of a molecule within a crystal. So in this case, water. All right. Using the same process, finding your atomic masses, find your molar mass, and do a percentage as if you're working out a mark in an exam, for example. Okay, the mark you got over the total possible marks times 100. Okay, we're asking for how much iron. There's 2 lots of those over the overall score, or molar mass, times 100. All right.